3/5 mg, replacing sine theta with 3/5, and that equals mass times acceleration. Simplifying that, I have t minus 4/5 mg equals ma. I'm going to draw a blue box around that because that is the first of my simultaneous equations that I'm going to use to find the value of A. The other one that I'm going to use is I'm going to resolve for particle B. Again, using resultant force equals mass times acceleration. And looking at particle B, there's only two forces acting directly on B, 2 mg going down, T going up. So the resultant force equation for B is 2 mg minus T equals 2 ma. Now that's important, mass times acceleration. The mass of B is 2m, so it's 2 ma. Okay? That one there was ma because the mass of A was m. The mass of B is 2m. It's very, very important that we get that bit right because that will affect solving our simultaneous equations. And that's the second one. So what we're going to move on to do now is we're going to solve those two equations simultaneously. So we've got t minus 4/5 mg equals ma, 2 mg minus t equals 2 ma. And as before, if we add those two equations, it cancels out the tension. 2 mg minus 4/5 mg is going to be 6/5 mg, and ma plus 2ma is 3 ma. Now the bonus here is the m's will cancel out because they're the same value, and then dividing by 3 we get that the acceleration is 2/5 g, and 2/5 g, working out 2/5 of 9.8 is 3.92 ms to negative 2, and that is the solution to part A. Right. Part B then is saying the time that elapses before B hits the horizontal plane. So B is going to hit the horizontal plane. Went the wrong way there. There you go. B needs to travel 1 metre to hit the horizontal plane. So this is a SUVAT question. And the reason that I know that it's a SUVAT equation is that the acceleration is constant. You can only use SUVAT when the acceleration is constant. So part B, we're going to use SUVAT. And we know that S is 1 because that's the distance that B has to travel before it hits the ground. We know that U is 0 because the system initially started at rest. And we've now calculated that A, the acceleration, is 3.92. And we want to know the time taken. So we need our SUVAT equation that's got S, U, A and T in it. So S equals UT plus half AT squared. These are in the formula book, which I think is absolutely disgraceful. I think you should be learning them. Because if you learn them, you become fluent in their use rather than having to look them up every single time you use them, costing yourself time and losing your train of thought of how you're actually even doing the question in the first place. So S is 1, U is 0, so 0 times T, so we've got a half times by 3.92 times by T squared. So 1 equals 1.96 T squared. I'm going to divide by 1.96 and square root. Now, calculator's gone over there. No, it hasn't, it's gone behind the camera, bear with. I think it's important there's a real life element to this. It doesn't seem two-stage, so leaving my calculator somewhere random in the room is obviously part of that. So square root that, you come out rather beautifully with t is exactly 5/7. Technically it's plus or minus because we're square rooting. Of course we're not going to worry about the negative because it's tiny. So that is part B. So that is the time taken for B to hit the ground. Part C, the distance A moves up the plane. What we've got to consider now is what happens to A when B hits the ground. Well, I'm going to draw out a new system for this. Because what will happen to A when B hits the ground is that its acceleration will change. And the reason that its acceleration will change is that if B hits the ground, the string is going to become slack, which means there's no more tension. So there's now no more force pulling A up the slope because the string that was doing that has now become slack and is not exerting any force causing A to move up the plane. So the only forces we have now to consider are the frictional force and the one that everyone always forgets, the weight component down the slope. So we've still got that mg we've still got those components. The one that I'm interested in, because it's acting parallel to the plane, is that one there, which is mg sine theta. So for A, we have a new resultant force equation. So resultant force equals mass times acceleration. What we have is, we don't have t anymore. So if I go back to what we did in part A, this was our equation of motion for A. What's happened now is, because B's hit the floor and the string's become slack, we've no more tension, and that's what we're left with. So I'm going to go with that. We're going to go with minus friction minus mg sine theta equals ma. They're both negative because A is still moving up the plane, so resolving in the direction of motion, friction and weight are acting down, they're acting against that, so it's opposite. They haven't changed in magnitude, so the frictional force is still 1/5 mg, and the weight component is still 3/5 mg, because sine theta is 3/5, that hasn't changed. So we now have negative 4/5 mg equals ma. We can cancel the m's and we can say that A is negative 4/5 g, which means that A is negative 7.84. So once B hits the ground, A will now decelerate. We should be happy with that answer coming out negative because we think, okay, well what's going to happen if there's no more force pulling it up? Well, it's slowing down. So it must have a negative acceleration, it's decelerating. And what we now want to ask is, how far does A travel before it comes to rest? At the moment, we don't have enough information to answer that question, because what we need to know is, what speed was A doing at the point when B hit the floor? So we're now going to calculate the speed of A when B hit the floor. And this is a SUVAT scenario again. We know that S is 1 because B had to go 1 metre down to hit the floor. We know that the acceleration during that stage of the motion was 3.92. We know that the initial speed was 0 because the system started at rest. And we know, because we calculated in part B, that it took 5/7 of a second for B to hit the floor. What that means is that I can use V equals U plus AT. So V is 0 plus 3.92 times 5/7, which means that V is 2.8. So, when B hits the ground, A is travelling at 2.8 metres per second, at which point it starts to decelerate. It has acceleration negative 7.84. So what now happens is V becomes U. Our final velocity now is 0, because we want to know when A comes to rest how far have we gone. Our acceleration is negative 7.84, and we want to know the distance travelled. So we're going to use V squared equals U squared plus 2AS.